There's a whole plethora of issues that have been in the rail industry for many years.
The existing crossings right now, about 50% of them are not connected to a wide area network.
The gates are down longer than required. So what you have is traffic that's backing up. If drivers are waiting at crossings too long, there's a tendency for them to try to circumvent the crossing gates.
The focus in the industry is to improve safety, and part of the safety component is to bring optimized crossing activations. The intent is to leverage existing systems and enhance it through the capabilities of the recently deployed positive train control systems.
With smart crossings and wireless crossings in specific, you now have an analytics piece and you now have a communication control system for the crossing that is independent of the rail itself. Smart Crossings does for highway grade crossings what PTC has done for wayside signals.
Positive train control is a train protection system designed to stop a train in case an unsafe condition is detected.
It's not any one product, it's a system of products. You have the grade crossings and you have the application engineering that we need to do associated with the wayside. The messages come from the onboard system onboard the train, and it's a feature, a function of the overall IETMS solution that we have, which meets PTC requirements.
With our product, we allow for more accurate warning times in the situations where you have station stops on predictor circuits. Our system will eliminate the pre-activation, so you only have the one activation.
This new technology eliminates the reliance on traditional track circuits or the consistency of that shunting between the wheels and the rails themselves.
There is no need for the disabling of crossings for maintenance activities that occur within the approaches. So that in itself leads to an increase of safety because we don't have to have someone disabling a safety system for work to be performed and then re-enabling it properly and testing it.
The system not only prevents train-to-train collisions, but also ensures that the trains follow speed limits through certain zones. The restrictions are monitored and enforced automatically, ensure the safety of the maintenance crew working on the track.
So for setting up the wireless crossings, it's integrated within the PTC system. So any train that has IETMS installed on it, we can install a simple software application. It's actually a licensed feature. So you just turn on this license. It'll allow for the wireless activation from the onboard perspective. On the wayside, a crossing control will need to be installed and the coding will need to be put into that crossing controller. But we'll use your existing communications backbone and the existing onboard backbone to establish the wireless crossings.
The train is approaching the crossing, being prepared to stop at a predetermined distance away. The red fence is active for that crossing. It establishes crossing communications with the WIU on the crossing, between the crossing and the onboard of the train. As this communications is established, the train then sends an estimated time of arrival to the crossing. The crossing then acknowledges what the estimated time arrival is. And the train receives the acknowledgement from the crossing and the stop fence is removed from the system on the onboard of the locomotive. The train then continues toward the crossing with updates, any changes to the ETA, status message from the crossing to the locomotive. The train then reaches a point where the crossing activates for the required warning time. The train reaches the crossing with the crossing still activated, and then the rear of the train clears the crossing and the crossing deactivates. Imagine again as the train is approaching the crossing, being prepared to stop at the crossing because it hasn't established communications with the crossing yet, and there's a red stop fence active for the crossing. So now as that train approaches the point of needing to establish crossing communications, and that communications cannot be established, that red stop fence remains in place. And that is a key tenet of wireless crossings in general, is that if the communications cannot be made and established, then the train has to stop. The train then continues forward towards the crossing, being prepared to stop at the stop fence before the crossing, and then the train stops at the crossing. At this point, then, the railroad's operating rules would take place on how to negotiate that stop at the crossing before the train can proceed. So the planned stop before crossing, which is what we call a near side stop, the train is approaching the crossing, being prepared to stop at the predetermined distance away. The red fence is active for the crossing. So as that train approaches that point of establishing crossing communications, the train purposefully doesn't establish communication with the crossing since it is stopping short of the crossing. This allows for the crossing warning system to not prematurely activate, knowing that we have a train that's going to stop at a station just short of the crossing. So the train then continues towards the planned stop location. The train then stops for either the change of crew or boarding of passengers. The train then is ready to depart. It starts communicating with the crossing. That can come as a piece of pushing a button on the onboard, and that again starts to establish a crossing communication. The train then provides the estimated time of arrival to the crossing. That crossing then in turn arms itself, knowing the ETA of the crossing, and then the crossing sends an acknowledgement back to the train of that estimated time of arrival. Then the train acknowledges and understands and goes ahead and lifts the stop fence from the planned stopping point at the crossing itself. The crossing activates with the required warning time for the train, and the train proceeds through the crossing. Once the train clears the crossing would then deactivate and everything would be sitting at a normal state again.
The data on every crossing activation and train movement throughout the entire network is available in one place. So we can analyze, compare, and demonstrate the performance of each event across the entire network. This can be very useful to obtain certification a lot faster than having to collect the same data manually at each crossing.
What the analytics system allows you to do is get real-time data from each one of these crossings to give us insights into how crossings are working, when they go out of tolerance, and figure that out very quickly, and to be able to tune a system for better overall performance.
Understanding predictive information so that you can do the deep dive into the big data of these interactions to really understand and predict potential future issues.
This data is also available in real time, giving us insights into the system performance at any given time. This will help us minimize some of the mandatory testing that needs to be performed periodically. Ideally, you want the barriers to be lowered as late as possible, minimizing the wait time for the road users.
Having connected crossings, having smart crossings, all leads to an efficiency play by the railroad.
I do believe that this technology is a game changer, and its potential, it's significant as well.